Assalamualaikum. My name is Fatin Nabila. My supervisor is Dr. Muhammad Inam Abbas, and my title project is Printed Implantable Antenna for Healthcare Application. So we will start first with project background. So first, implantable antenna are widely used in my biomedical application. So it is the key component for bidirectional with the exterior control equipment or with exterior monitoring system. And then second,
sorry Fatin,
yes.
sorry to disturb you. Can everyone see Fatin's slide? Because I cannot see.
No, I cannot see.
I think Fatin hasn't opened the slide yet, right?
Yes.
I have opened the slide.
But you
Why?
don't show your slide, Fatin. Show your slide, Fatin, not your desktop, because you are showing your desktop right now.
Share the PowerPoint. Oh, wait.
Ah, yes. Okay.
Is it okay now?
Now we can see. All right, proceed.
Okay. So second, the implantable antenna are designed to operate on specific frequency band, namely the Medical Implant Communication Service (MICS). It is at 402 until 405 MHz. Microstrip patch antenna is used to design antenna because it permits compact size of antenna with low manufacturing costs and easy fabrication. It is because why the size must be small. It is for the comfort of the patient. If it's big, then the patient will not feel uncomfortable. Then we proceed to problem statement. There are 3 problem statements. So why we choose to design implantable antenna? Implantable antenna need to be designed with broadband performance in order to reduce the shift in resonant frequency due to non-homogeneous human tissue. For implantable antenna, it is challenging because usually antenna it will operate in free space, but because of it is implanted, they will be detuned in frequency if we do not design properly. And then internal condition of human body is not favorable for high power antenna radiation. Hence, the antenna gain had to be very low for implantable application. Antenna size has to be as minimal as possible so that it can integrate with other implantable devices like pacemaker. So, this is objective for our project. First is to design miniaturized microstrip patch antenna for implantable application that will operate in MICS band frequency range 402 to 405 MHz to optimize the performance of designated antenna based on the safety standard and requirement of implantable application. To measure Sorry, madam, I cannot see the number 3. To measure and analyze the performance of the proposed microstrip patch antenna inside the liquid phantom developed for MICS band 402 to 405 MHz. So this is scope of the project. The project is only limited to the microstrip patch antenna, specifically to the usage in biomedical application. The frequency band is between 402 until 405 MHz according to MICS standard. Microstrip patch antenna will be designed and simulated using CST Microwave Studio, and then we will build phantom box using CST Microwave Studio. Phantom box represent the human body. microstrip patch antenna will be put inside and measure its performance to see if the antenna fulfill design specification. So this is the literature review. I have compared from five research, and then from the research, I saw that most of the researchers use two type of substrate, that is Rogers and FR4. And then the design type that they choose is P4, planar inverted antenna. And printed dipole antenna is the most used by the researcher. And then miniaturization technique that is the most used by them is meandering line on the patch. So proceed to methodology. So this is the antenna design flow chart. So first, I do literature review about implantable antenna. It's really a long time because it's a new topic for me. I haven't learned it yet. And then study about antenna design and study about CST software, how to design the antenna, and then determine required parameter for implantable antenna, like what kind of substrate that I should use, how to measure the performance, the bandwidth, the gain, how can to get a good antenna, and then selection of the electric material, what kind of electric constant that I would use, what kind of substrate, study about phantom properties for human body equivalent. So I study about the human tissue. They are made of 3 layers: skin, fat and muscle, and what is their conductivity, permittivity, and then design antenna in CST Microwave Studio. This is will be in part 2 of the project. Then design optimization using different parametric strip. So how to optimize the design? We will look at the straight parametric, and then antenna simulation inside the phantom box. So does the antenna design meet the requirement? If yes, I will compare the measurement with other researchers to see if there is any improvement. And if no, I will simulate the antenna inside the phantom box again. Then this is the example what I would do in the second project. Next, first is I will design, and then the simulation of microstrip antenna in simulation software. So my expected result is theoretically the design antenna should be able to operate at MICS band within the 402 to 405 MHz with optimized dimension, has smaller size compared to the antenna available. Validation of all results using the CST simulation inside the phantom, which is representing human body, and also simulation for significant parameter as well as to see the performance of the antenna. So that's all. Thank you.
Right. Thank you, Fatin. You are within 10 minutes. Thank you for, complying the timing rules. Mr. Safirin, is there any question or remark from you?
Thank you for the presentation, Fatin. For me, it is too early for me to comment what is going to be later. But for now, I think if possible, because you are going to design a microscript patch antenna, right? So
Yes.
the things here is you must be careful with all the design and to ensure that all the materials that you have is within your limit and back to your objective and what do you want to achieve at the end of this project. And for me, good luck. I wish you good luck for your next project, and I hope it will be done within the time given to you later. So that's all from me.
All
Thank you,
right.
sir.
Okay.
Thank you, Mr. Safirin. Very good advice and very inspiring. All right. Fatin, I have one question for you. Um, could you please go to your expected result?
Expect the result.
Yes,
Okay.
your expected result. Okay. Before I ask my first question, my pre-question is: are you going to fabricate your antenna?
Oh, at first, before the MCO, I plan to fabricate antenna, but
Okay.
with the situation right now, I will just design the antenna,
All
and
right.
we will do 4 type of substrate.
Mm-hmm.
Based on 4 type of substrate, FR4, Rogers, many type of Rogers, but
Many type
within
of several type of
several
projects,
type of
right?
Rogers, several type of Roger,
Okay.
range from 2 to 5. Range of the substrate is 2 to 5.
What range?
I mean, the substrate will be I will use for Rogers is like 2, right? 2.2 like that. So
What I mean,
uh,
4 Rogers. You mean you're going to use 4 Rogers material, right? 4 types of Rogers material.
no,
So
no.
each,
I will use FR4 and Rogers.
okay, FR4
Yes.
and Rogers only two
Uh,
different materials.
and yes.
So this one you're going to use. You're going to design by using simulation only, right? You're not going to fabricate, correct or not?
Yes.
Okay,
Not going to
okay.
fabricate.
All right, good. It's okay. All right. Back to your expected result. You said that the design antenna should be able to operate at MIC band, right? So you
Yes.
gave the frequency band 402 and 405 megahertz. So may I know, based on what parameter or how are you going to confirm that your antenna operate properly? Based on what?
Oh, so based on the return loss, it
Okay.
must it must have under 10 dB,
Mm-hmm.
and then the bandwidth it must be within the 402 to 405,
Mm-hmm.
and I will VSWR,
Mm-hmm.
E field, H field, surface current distribution.
Mm-hmm.
SAR also must be within the specification for IEE standard.
All right. Okay,
Okay.
thank you very much, Fatin.
Okay.
Mm,
For
oh, ada
the
lagi? Bagus, Fatin. Tanya sikit jangan banyak. Alright.
no, I want to correct earlier. The substrate it
Mm,
is RT Dura, FR4 and Rogers.
do you
4 type.
right? So,
Yes, you're right.
do you right? Okay. Um, what are the differences between the materials?
The dielectric constant.
Okay. All right, Fatin, I'm quite satisfied with your answer. Thank you very
Okay.
much.
Thank you, madam.
So, can we go to the next presenter?